Today I will explain some lean principles based on the example of a bike manufacturing process. The lean principles that are covered in this video are Kanban, 5S, SMED and Poka-Yoke. Some slides might contain a lot of information, therefore be advised to sometimes pause the video in order to have a closer look. In order to manufacture a bike in our example, you first need metal pipes. The metal pipes get cut into the right length. After that they get curved and then welded in order to become the bike frame. After that, according to the customer demand, the bike frame gets colored, and in the last step the bike gets assembled with some further buy items and shipped to the customer. However, this is obviously a simplified process for the purpose of this video. In order to make this production happen, a bandsaw is used for the cutting of the metal pipes, a bending machine is used to curve the pipes, a welding machine is used to connect the pipes to a frame, a paint gun is used to color the frame, and assembly tools such as screwdrivers, pliers, etc. are used to fit the remaining parts together with the bike frame. The current production is a mass production with the typical push system. The problem with the current system is that we have a lot of inventory and inefficient processes, which ties up capital and leads to a long lead time. Furthermore, the final assembly process lacks standardization, the coloring process has a long lead time, and the cutting process produces a lot of unusable parts. But more about that in a second. The triangle symbolizes the inventory between each process with the number of parts it holds on average. Starting from this current state map, we want to use the lean principles Kanban, 5S, SMED and Poka-Yoke to improve the process. Let us first have a look at Kanban. Here the customers demand a certain number of bikes of different colors, which can be seen in step 1. Then the production control takes the recent data and creates a forecast for the next week accordingly, seen in step 2. This forecast is then used to schedule the production via the Hayunka box in step 3. In the Hayunka box, the planned production of bikes for the next week can be seen, and the Hayunka box is used to produce just as many bikes as demanded. The Hayunka box is a rack with several rows and columns. Each row stands for a different product type and each column for a predefined time interval. In our example, the different product types are bikes with different colors, and the time interval is 2 hours. The Hayunka box contains so-called Kanban cards with information about the individual product types and batch sizes. In our example, the Kanban cards contain information about the bike color and the batch size is 1. The production control determines the demand of each bike color for the next week and places the Kanban cards into the rows according to the bike color, and distributes it along the rows with the goal of minimizing the batch sizes. Since in our case the batch size is 1, this factor can be neglected. But in general, small batch sizes have the advantage that they reduce average inventory and increase the responsiveness of the production according to the customer demand. There are 2 categories of Kanban cards: withdrawal Kanbans and production Kanbans. The Hayunka box has only withdrawal Kanbans, but more about that in a second. First, I want to explain how the Hayunka box is linked to the production. The Kanban principle usually requires a so-called milk runner. The milk runner is a person who is responsible for transporting Kanban cards, which is basically just information. And the milk runner is also responsible for transporting parts, in our case bikes, along the supply chain. In step 4, you can see how the milk runner, as the first thing in the morning, goes to the Hayunka box and picks up all Kanban cards that are placed in the column for the first 2 hours. 2 hours because this is our predefined time interval as mentioned before. With those Kanban cards, he walks to the inventory just before the shipping process. The inventory is physically still the same as it was before, but the logo has changed from a triangle to a shelf-like symbol since the inventory now functions in a very different way and is therefore called supermarket. So from now on I will call the inventory supermarket. Once the milk runner has arrived at the supermarket, he will do step 5. The supermarket, where step 5 starts, already contains products, and thus the milk runner takes those products according to the Kanban cards he carries with him, removes the production Kanbans that are attached to those products that he just found, attaches the withdrawal Kanbans he got from the Hayunka box, and carries the products, together with the withdrawal Kanbans attached to them, to the shipping area. The withdrawal Kanban stays attached to the bike until the bike gets shipped. This ensures that the storage in the shipping area does not get too big, and that the production control is aware about the number of bikes currently being in the shipping area. Therefore, step 6 only happens immediately after step 5 if any bikes were shipped recently. bikes were shipped recently, step 6 happens, where the milk runner picks up the withdrawal Kanbans and brings them back to the Hayunka box, so that the production control knows that bikes were recently shipped. However, the milk runner does not pick any new Kanban cards from the Hayunka box, since the 2-hour interval has not passed yet and there is no further bike production due yet. However, if there were no bikes shipped recently, the milk runner skips step 6 and continues with step 7. In step 7, the milk runner takes the production Kanban, which was removed from the bike at the beginning of step 5, and brings it to the final assembly process. This production Kanban now tells the final assembly that they are supposed to assemble another bike. If there is a bike already assembled at the final assembly area and is waiting to be transported to the next supermarket, step 8 happens, where the milk runner will recognize this, will remove the withdrawal Kanban from the bike, will attach a production Kanban to it, and will carry the bike from the final assembly area to the next supermarket. In step 9, the milk runner will take the withdrawal Kanban that was just made free in step 8 and will bring it to the previous supermarket. Then the milk runner will identify the right colored bike frame according to his withdrawal Kanban, will remove the production Kanban that is attached to the bike frame, will attach the withdrawal Kanban he just brought from the final assembly area, and will carry the bike frame with the withdrawal Kanban attached to the final assembly area. With the use of the Kanban cards, the communication flows from the final customer all the way to the metal pipe supplier and ensures that only the amount and the type of bike is produced that is actually needed. The principles that I explained continue in the same way, which can be seen in steps 11 to 16. The milk runner does not have to follow the numbering that I used here though. The numbers were just used for explanatory reasons. At the same time, the milk runner definitely has a fixed route and he has to return no later than 2 hours after he started his journey in order to get the next batch of production orders from the Hayunka box to the supermarket of the pacemaker process, see step 4. But wait, what is a pacemaker process? The last process that is not following a FIFO principle before the shipping area is called pacemaker process in the pull system. In our case, this is the final assembly process, and the reason why it is called pacemaker process is that in order for this whole Kanban system to work, the individual processes have to have very similar processing times, and therefore the final assembly determines the rhythm or tact that the other processes upstream the production have to comply with. This tact or rhythm that is determined by the final assembly process makes the final assembly process the pacemaker process. Now I want to explain the next lean principle, which is 5S. 5S stands for sort, set in order, shine, standardize, and sustain. Since the assembly area was very messy and every operator seemed to have his own approach, which was sometimes not efficient at all, change was required. 5S helped to remove these kind of issues. First, with sort, all unnecessary items were removed. With set in order, every item got a specific location assigned. With shine, it was ensured that the work area is clean. With standardize, a certain efficient work procedure was established, documented and shared, and with sustain, regular meetings were implemented to ensure that the new standardized way was maintained and in order to initiate further improvements. The next principle I want to explain is SMET. SMET stands for Single Minute Exchange of Dies and is a certain method to reduce changeover times. Before applying SMET, there was a long changeover time required at the painting process, since getting a new color from the central storage area required a lot of walking. By ensuring that there's always a small stock of colors next to the painting area, the changeover time could be drastically reduced from 10 to 2 minutes and therefore be reduced by 80%. The final lean principle that I want to explain is called Poka-yoke. Poka-yoke makes processes fail-safe. Before Poka-yoke was applied, many pipes at the cutting area were unusable due to measurement inaccuracies that led to inaccurate cutting operations. By creating and allowing the use of templates, not only could the number of unusable parts be drastically reduced, but also the process time could be reduced by a lot. After implementing these 4 lean principles, the changes were documented in a future state map, which shows the changes compared to the former present state map. Both the lead time and the process time could be drastically reduced in our example. Now the future state map is our new current state map, and we can look for further lean principles to be applied in order to ensure continuous improvement, which is also called Kaizen and which is another lean principle. This allows us to also in the future supply the world with our high quality bikes. I hope this example helped you understanding the Lean principles, and thank you for watching.